Okay, this is my extra credit attempt at midterm 1, question 3. It deals with PMP transistors. The first part is to kind of label the diagram and show current and polarities on each branch. Okay, here is kind of a helpful diagram of the PMP that shows current direction coming in and also coming out. So it's current coming through the emitter into the transistor and out both IB and IC. And we can see that with this little equation here. So with that being said, our current comes through the emitter, IE, and out the base, and also out our collector. And the way I kind of understood it or rationalized it was between the voltage between B and E here is forward bias. So I look at it as there's more potential up here. Has to be more potential at the emitter to cause current to flow through both B and through C. So I kind of mixed up my sign convention at first, but going back to this, I'm labeling E as negative and B as positive, as well as the collector being positive, to show potential difference going these ways and causing this current to flow. And the voltage between B and C is reverse biased, and that would mean that there's more potential here at the collector than at the base, and kind of explains why current flows out of the base. Anyway, I need to move on. Okay, so this is my labeled circuit diagram or element diagram. Onto the question. So the question says that there's a microcontroller, the Arduino, putting out 5 volts, and this is just based on the circuit diagram from the question. Here's our microcontroller. It also says we have a source voltage of 5 volts. So, not sure if it's correct, but initially I was thinking that because if you've got 5 volts here at the emitter, and 5 volts here provided by the Arduino or the microcontroller, the Arduino, if there's 5 volts here and here, there's no potential difference, and current's not able to flow through this little B leg, and essentially rendering this transistor in cutoff phase is what I was thinking. And also, I went ahead and labeled C. The voltage at C is going to be 0 volts. So this is kind of initially what I thought. I proceeded to do the large signal analysis using the kind of the given diagram and relabel them again. And the two conditions that are required to be in cutoff are that the potential between this leg and then this leg have to be greater than negative half a volt. And we can see here that the difference between 5 volts and 5 volts, that potential is 0, which is greater than a negative number. And then we also have a 5-fold difference here. So both of these kind of check out and determine that it's in cutoff. Okay, thank you. Hopefully that's on the right track anyway.